CIT 1121, Module 8 and 8.1. 8 gets into the network layer. We're going to move up the OSI model. We just finished the data link layer. We are now at the network layer, and that is where we're going to talk about packet headers, and that is where we begin here. In this section in 8, there's really 3 subsections. There is the network layer characteristics, which we'll do with this video, and then there is IPv4 headers, and then IPv6 headers. And well, there's a 4th section. There's like how host routing works. That really bleeds into what's in Chapter 9. So those kind of go together, and we'll have videos for both 8 and 9 ready for tomorrow. So let's take a look. Network layer characteristics. Starting off with, I just grabbed one slide for this entire section because there's just a couple of things I wanted to talk about here. So when they start showing these IP packets, these are really protocol data units. It's not like they're traveling by themselves, which they don't make exactly apparent here. What they are trying to make apparent, though, is that the information as it traverses from one network to another. And how do you know if you're going from one network to another? You're crossing a router. So a router is going to read the IP addressing information, whether it be IPv4 or IPv6, and we'll get deeper into exactly how that works really in the next couple of weeks. But for now, just know that there's an address value that is going to be read, and that address value is going to be compared for exit interfaces. So for instance, if we had a computer over here, and that computer is router A, and we wanted to go over here to router B, A is going to supply router B's IP address inside of the packet header. And as that arrives at this router's got, in this case, 3 choices as to how to route the information to get it closer to router B. It could send it up high, it could send it across the middle, and it could send it down low. And it just depends on the routing table in that router as to which direction it's going to send it. Now, in this case, they've kind of given like a orange hue behind the top line. So it looks like when this router reads that destination IP address on this particular packet, it's going to say the best way for me to get to the network that device B is on is to send it up here to this router right here. When this router receives it, it also has choices. It could send it back the way that it came. It could send it straight down over to this router here, or it could fire it off to this router, which is actually connected to router B. Now, the decision made by this router is not influenced by this router at all. There's no influence between the routers. A router receives IP packet. It reads the destination IP address. It makes a forwarding decision based on its internal routing table. So A figures out that the traffic is remote. It forwards it to the router. The router receives it. It says, oh, I know where this is. The best path is up into this other router. This router receives it and it goes, oh, I know where that network is. My best path is down this way to this router. And then this router here says, oh, I know where that's at. And it sends it off to device B right here. And we've got ourselves half a line of communication. Of course, everything on the way back also has to work. So this router, I'll just make an X there, and this router both have, well, maybe, or this router need to know where the network that A resides on is so that we could send traffic back. And it doesn't have to take the same path. It could take a completely different path than the path that it arrived on. It just depends on what the routing table believes is its best path to the destination. So we could ride the wave across the top on the way there and ride the wave across the bottom on the way back, and it would be totally fine. That does happen sometimes. So the one thing about this is they do call it an end-to-end routing system or end-to-end addressing system, because you're going to use the IP address on device A and B, and that is from one end to the other. There are 2 different addressing systems that you need to be aware of. One is called IPv4, and the other one is called IPv6, and we're going to get more familiar with those in the next couple of slides. It is a static transmission, which just means this, that none of the information inside of the packet header is going to change from source to destination unless a special protocol is utilized. There's something called NAT, which does change source and destination IP address information. But the rest of the information is going to be static. It's going to, as it's created at the original sending host, it will be received by the original destination host. Okay? The other part is it's known as a connectionless protocol. When they talk about a connectionless protocol, what they mean is this. It just means that there's no mechanism that says, hey, tell device A that the traffic didn't make its way all the way over to device B. That something really bad happened here at router 2, and things have gone awry, and this whole system is down, and you can't go to school anymore, and this is up. Anyway, you get the idea. So there's nothing that's going to bounce back to A and let it know that it didn't get to where it was going to go. The thing that does that is actually at there's a higher level protocol. There's something called a segment header, which is going to keep track of packets for us when we do TCP. So we'll deal with that then. But as far as we're concerned, at layer 3, or at the IP header value, there is no connection-oriented resubmission or retransmission application within that within the information that's in that header. Okay? Hopefully that makes sense. I think that's pretty much it for the first part of Module 8.